Hello dear students, welcome back again. In this session we are going to discuss about PLA, that means programmable logic array, and about FPGA, field programmable gate array. Okay, so these are the device actually, or microchip, where we can design our own hardware. We can implement our own logic circuit. Okay, so in PLA, first we start with PLA, programmable logic array, and before that it was I think PAL, programmable array logic. So programmable array logic, then programmable logic array. Actually these two are the same thing, different people named in different way. Then PLD, programmable logic device, and then we got FPGA. Okay, so take a look, what is PLA? A programmable logic array is a kind of programmable logic device used to implement combinatorial circuit, logic circuit, as I told you. So any logic circuit can be implemented in PLA. The PLA has a set of programmable AND gate plans which link to a set of programmable OR gate plans, which can then conditionally complemented to produce an output. So usually we say it ORs of AND, that means summation of the multiplications. Okay, you can take a look here. Like this is our logic, our logic, how to say, logical expression. Okay, Boolean expression. We understand we have A, B, C. So we have to build a logic circuit to get this output Y. Okay, so how we can do it? We can draw a corresponding truth table, and then we can get the output. So actually we can do it by a sum of product concept. So take a look here. On left side, the inputs come to a unit where they have the connections with all the AND operations or AND gates. Okay, so when input is coming, like here, this is A, and also another input A dash. Okay, in the same way, B and also B dash. Now if I want to make A, B, then this one and this one. So we can implement a AND gate where these two can be connected. Okay, in this figure it's showing a bit in different way, like it's showing AND gate with all the connections, like one connection, another connection, another connection, another connection. The point is, we can program our connections. Like if we want AB, then we will not consider this connection. We will not consider this connection. We will implement this connection and this connection. But we are not having any connection over here. So this will give me A, B. If we use another one here, where we want output like A, B dash, in that circumstances, which connections will be connected here? You can see A and B dash means here. So in this way we can get the product value of A and B, and then some value. This value can be now be a part of OR gate. Like if I wish just AB, then I will have a connection here, no connection here. But if we want connection, if we want the output AB plus AB dash, then this one and this one should be connected. Okay. In the same way, if we want another things, like if we want a output, like AB plus A dash B dash, what should I say? A dash means here and here. Then we have to ensure the connection. Where is AB? Here is AB, and A dash B, this is A dash B dash. So yeah, you can get this connection. So this is the way how PLA works. Okay, programmable logic array works. So when it will become a device, it called programmable logic device. Okay, PLD. Okay, so this is the sum of product. That is the main concept behind PLA or PLD. Okay, yes. So you can see here in this picture, you can see this is unprogrammed, and here you can see the programmed PLA. Okay. As I discussed here, you can understand by using by watching this picture, you'll be able to understand it. Okay. So here there are three outputs for Y, X, and W, and as I mentioned here, you can see in the same way it's building that kind of output. Now here is glue logic. So glue logic is the combination of this kind of different type of logic units. Okay, like AND and OR a processor and a memory. So if we read the definition, glue logic is a special form of digital circuitry that allows different type of logic chip or circuits to work together by acting as an interface between them. Okay, so in this example, we used a AND gate type of logic circuit with a OR type of logic circuit, and these are the interfacing between these two. So these type of circuits are called glue logic. But glue logic, this concept is more applicable or will be more familiar when we will discuss FPGA. So as an example, consider a chip that contains a CPU and a RAM block that can be considered as glue logic. Okay. So as I told you, since we have this type of logic circuit, then this kind of logic circuit, and this kind of logic circuits, and all these connections can be programmed. Okay, these connections can be programmed. We can program any connection of this configuration. On that circumstances, this system is called programmable logic array or programmable logic device. Okay, one unit, one block is called one PLD. Okay, so there can be a number of blocks, a number of PLDs together. In that circumstances, we call it complex PLD. Like this is the block, you can see in the figure. Okay, so there are 4 blocks here, having some input output and having some feedback with the bus, okay, or with the connections, internal connections. This kind of complex structure is called PLD. Okay, so PLD, each PLD is a sum of product of logic circuits or logical devices or gates, and complex PLD is the combination of some number of PLDs. Now, there is another issue we need to learn to understand about FPGA. What is gate array? A gate array is an approach to design and manufacture an application-specific integrated circuit. Application-specific. It might be a processor, it might be a RAM, it might be a ROM, it might be a interfacing unit. Okay, so whatever it is, any type of application specific integrated circuit, which is shortly called ASIC. If you'll make a search on Google by writing ASIC, you will see this, how to say, this issue. Okay, so using a prefabricated chip, like one chip is available where we can build a RAM, where we can build a processor on a prefabricated chip, okay, with a component that are later interconnected into a logic device, okay, according to a custom order by adding metal interconnected layers in a factory. Just take a look on this figure. Here there are some configurable logic block, not this but kind of this logic block, having some connection box, like this kind of connection box, and switch box. Switch box means which connection will be turned on and off. This logic can be implemented in the switch box. So FPGA is a device where different type of things can be used, like a like different type of logic circuits. Okay, in each block have a different type of logic circuit, and they can be combined together. That is the concept of FPGA. So for gate array, again, a gate array is an approach to the design and manufacture of application-specific integrated circuit using a prefabricated chip with components that are later interconnected into logic device according to a custom order by adding metal interconnected layer in the factory. Okay, so actually FPGA is a gate array and it's called field programmable. So field programmable gate array, the definition will be similar to that one. The field programmable gate array are semiconductor device that are based around a matrix of configurable logic block, which is called CLB, as I told you here. Okay, so semiconductor device that are based around a matrix of configurable logic block connected via programmable interconnections. Okay, so the connections are programmable. You can see here the connections are programmable like these. Okay, so FPGA can be reprogrammed to design to desired application or functionality requirement after manufacturing. So this is a programmable, field programmable. That means we can change it. We can change the program. Like once we got a requirement from a user used it, but he wants some change on this hardware, okay, on this logic circuit. We can do it. Okay, so that way this is saying, yeah, it's reprogrammable. We can change it, not like a PLA or PLD. PLD is one-time unit. Okay, once we have programmed it, it cannot be changed. Okay, but for FPGA, it can be changed. Okay, So here again you can see this architecture. So you can see here the four things together are called are working like a routing channel, okay, where should have some IO, should have some input and output pins, okay. CLB, that means configurable logic block, a connection box and a switch box, okay. Actually the CLB and the switch box together is a unit, works like a unit, okay. So you can understand in a FPGA there are a number of this kind of CLBs, okay, configurable logic blocks. Here is a bit, how to say, enlarged figure of the FPGA structure. Here it's just showing it can have IO, input output, and a CLB block and a switch block, okay, or the interconnection network, okay. So you can see here inside the CLB, so CLB is a configurable logic block where we can make any kind of logic output or logic circuit from the input. Like if we have like suppose in this block we have three inputs A, B and C. A, B and C. We want an output like A dot BC plus ABC plus A dot BC dot plus A B dot C. This kind of logic operation we want from this block. It is possible. So any kind of logical operation for these inputs is possible in this CLB or programmable logic block, configurable logic block by using a lookup table. Okay, so those who have interest on FPGA, please study deeply about lookup table and about the CLB and about the connections, and you can see understand the connections here. Okay, you have all the connections as you program. I have erased it. So the connections can be programmed. Okay, we can program the connection. So number one, we can program the logic circuit. In the same way, the connections also can be programmed. So a number of blocks are there in FPGA, and all the CLBs can be configured. That means logic circuit can be implemented, and they can be different CLBs or block can also be integrated by using its bus or connection logic. Okay, so that was the concept of FPGA. Again, in this course, our target is to introduce you the modern tools or modern processing units or modern systems, so that you can think deeply, okay, or you can think what kind of things I need to use to implement this kind of systems. Okay, since in future IoT is coming, AI need to be implemented inside the edge computer. Okay, or a number of how to say, different type of image processing, different algorithms of AI need to be implemented inside how to say, inside a system or home automation system or inside a car automation system. So in that circumstances, you need to take the decision, or you need to find which processing unit or which kind of devices, which sensors is necessary for implementing this thing. Okay, that's why I introduced a number of things in this single course, so that you can think, you can imagine new things. Okay, so that was my idea. It was the introduction of FPGA and PLA, just an introduction. If you want to learn more you have to learn by yourself. Okay, thank you very much.